Okay, so today in class we went over a little bit more about composition of functions, and we also introduced some ideas about the domain of those compositions. So first of all, let's compose f composed with g of x. Now if you remember, that notation is similar to this one, f of g of x. And so g of x is the input function into the f function. So what we want to do is place the g function into the f function. So here's the f function with a gap for what x is, or where x is, and we are going to place g into it. And now we'll just simplify it down, and the square root of x squared is x plus 1. G composed with f of x is next, and that means that f is going to go into the g function. So here's the g function with a gap for x, and in there will go f, which is x squared plus 1. And there is no simpler version of the square root of x squared plus 1. It is just the square root of x squared plus 1. So with those in mind, those are the compositions. And then the second part of this, we're supposed to identify the domain of each function. And so let's go back to this first function right here, f. F was defined to be x squared plus 1. It doesn't have any square roots in it. It doesn't have any fractions in it. So the domain of f seems to be all real numbers. The g function is the square root of x, and we know we don't want to ever square root negative numbers. So the domain of the g function is x such that it's always greater than or equal to 0. Now this composition of f composed with g, it ends up saying x plus 1, which appears to be all real numbers could be used, because I can add 1 to anything. However, you have to carry forward, or have to at least be aware that the input function of g had restrictions on the domain. And those restrictions carry forward because the very first thing you're going to do is plug a number in under the square root to find out an answer, and those numbers can't be negatives. So the composition here, f composed with g, also has the same domain of x is greater than or equal to 0. Does not look like it at the end. But because of how we're going to get this end result, we have to square root a number, square it, and then add 1. We cannot use negative numbers under this square root. Now the g composed with f function is a little different. We're taking f and putting it into g, and by doing so, f had all real numbers possible, and I think if you reason this out, you would square any possible number you ever think of, it's going to be positive. Add 1 to a positive number, it stays positive. Therefore, we can square root anything that you can think of. And therefore, the domain of g composed with f in this case is back to all real numbers. So I've attached a sheet kind of to explain this a little bit if I'm not getting it across very well here at the end. Let me direct you to the last few pages of this video here at the end, and there's a summary of what this is talking about there as well in written form. So we'll move on from here, but we might come back to this at the end. Okay, the next thing we want to be able to do is decompose functions. If we can use fog or f composed with g of x to put together an interesting composition, we want to decompose those here. So what we're basically saying is, what is function f and what is function g, so that when I form the composition, I get this square root of x plus 6. Okay, what is f and g so that I get the composition the square root of x plus 6? Now the simplest way to do this is to look at what has my attention is in under the square root x plus 6. I'm going to let that be the g function. And then how would I make x plus 6 become the square root of x plus 6? I would need to place it under a square root and so I'll call f the square root of x. Now, if I ran the composition of f composed with g of x, would that indeed make this h of x function? And the answer to that should be yes. There are many different ways you can decompose functions. There's not one set right answer, but this is one example. I always look at the part that's been put in and try and get that to be the input function. Okay, so let's carry that decomposing idea forward here too. We would like to decompose h of x into an f of x and a g of x, such that when we would compose f and g, we would get h of x. So what do you see here? What I see is this part right here as the inner input part. So g of x, I'm going to let be x squared plus 1. In order to get it to look like all of this h of x business, I would have to have 2x cubed for that to come into. Now, would that, just in your mind, kind of make sure this is going to work? If I take g and I put it right in there, would that come out looking like h? And I think it would, and that therefore I have decomposed this in a way. There are other ways to do that as well. If that's not the first thing you saw, there are clearly other ways to decompose this function. Today's assignment is on page 89. I think it starts there on 89 and continues on if you have to turn the page, but 31 to 41 odds, 47 and 51 also. Please practice those, and we can discuss any questions you may have next week. This is just a kind of a website that I found that kind of visually shows you what composition looks like, and also then gives you some very good examples of the domain. Please make sure you understand these steps right here for finding the domain of those functions. This page is just a few of those example problems they've provided. You don't have to do these by any means, but should understand what's going on in. And finally, if you really are struggling with these compositions, maybe try some of these here at the bottom, whose answers are provided here. The answers provided here for those 6 problems. So composition isn't necessarily a tough thing, but I do think the domain sometimes gets a little tricky trying to understand what the domain of those compositions are. So if you have any questions, please speak up in class about that.